So, good afternoon, everyone. Today we are discussing probability. So, first we understand the meaning of probability. So, what is probability? Probability, that means that is something which is not sure. We are not 100% sure about the results. So, probability is chances of happening or not happening of an event, happening or non happening of some future event. So, as you know, future is uncertain. We can't predict with certainty what will happen in future. So, we'll always have certain percentage that we'll say that today it will be rain. There are 75% chances that rain will occur. So we are not sure. So that's why we have attached some percentage to that. That percentage is called probability. So probability is chances of happening or non-happening of some future event, as future is uncertain. So if we divide the events, events are of two types. One is deterministic events and second is probabilistic events. Deterministic events are those whose outcomes are already known. We know the outcomes. What will be the outcome of that event? If the outcome is already known, then such type of events are called deterministic events. And probabilistic events are those events whose outcomes are not known. We can't predict what will be the actual outcome. So we always assume certain probabilities. So whose outcomes are not known in advance, that is called probabilistic events. So for example, who will win the match? We don't know with certainty who will win the match. Then we say 50% chances are that Argentina will win the match or some other country will win the match. In that case, we use probabilistic events. But if we say if multiplying 2 by 2, we know that the answer is 4, then these are called deterministic events. So events whose outcome is already known in advance, they are called deterministic events. They are called sure events, and whose outcome is not known, it depends upon certain future events. So that is called probabilistic events. And the purpose of probability to find out the chances of happening of that probabilistic event, that is called probability. So probability is a subjective approach. So generally it depends upon the facts and the evidences available to the person. But that is basically the subjective approach. But if we ascertain the favorable cases, how many events are favorable in happening of that event, so when we compute probability with that thing, that the results are more accurate. So probability, if we compute the probability of an event A, we say how we can compute probability of A is chances, favorable chances upon total number of cases, or you can say number of favorable cases upon total number of cases, that will be the probability of event A. So before understanding the concept number of favorable cases upon total cases, before understanding the concept of probability, there are certain concepts which you must understand. So concepts of probability, first we'll explain these terms. Concepts of probability. So the first concept is experiment. You must know the definition of experiment. Experiment is conducting a trial. Experiment is conducting a trial to obtain some statistical information. To obtain some statistical information or happening of an activity. Happening of an activity. That is called experiment. Now, for example, tossing a coin, that is an experiment. Rolling a dice, that is an experiment. Means whose outcomes are not known in advance. Outcomes are not known in advance. So that activity is called experiment. That's why we say experiment, because we don't know what will be the result of that experiment. So trial whose results are uncertain, we can't predict, that is called experiment. So outcomes are not known in advance. This is experiment, and these are the examples: tossing a coin, rolling a dice, drawing a card from a pack of cards. Okay, so all these are experiments. Now after experiment, the second term is event. Event is possible outcome of an experiment. Possible outcome of an experiment, that is called event. Now, what are the results? That all results are called events. For example, if I toss a coin, the possible outcomes are either head is there or tail. So we have two events. One is head event and second is tail event. So these are the possible outcomes of tossing a coin. Then if I roll a dice, then possible outcomes are that it will show 1, 2, 3, 4, 5, 6. All these are individually called events. So possible outcome of an experiment is called event. Now after events, the next concept is exhaustive events. Now what is exhaustive events? Total possible outcome of an experiment. Whatever the outcomes are possible of an experiment, all these outcomes are called exhaustive events. So total possible outcomes of an experiment. For example, in the case of tossing a coin, the possible outcomes are head and tail. So we'll say these are the exhaustive events of tossing a coin. Now if I roll a dice, that all possible outcomes are 1, 2, 3, 4, 5, 6. Collectively it is called exhaustive events. So total possible outcomes of an experiment, they are named as exhaustive events. An individual outcome is called event. So don't get confused with the definition of event and exhaustive events. Now after exhaustive events, the next term is the next term is mutually exclusive events. Exclusive events. Now before explaining mutually exclusive events, I'll explain equally likely events. Now what is equally likely events? Those events whose probability of occurrence is same. So equally likely events are those, the probability of occurrence, equally likely events are those two events are said to be equally likely are said to be equally likely if probability of occurrence of both the events are same. Means chances are equal. Both the events are same. For example, if we toss a coin, the probability of head and probability of tail both is equal. It means there is a 50% chances that head will occur or 50% chances that tail will occur. So they have the same chances. So if the chances of happening of these events are equal, we'll say that events are called equally likely event. That means they are random events. They are random events or unbiased events. There is no biasness in the selection. So that events are called equally likely events. Next we have mutually exclusive events. Now the definition of mutually exclusive events is two events are said to be mutually exclusive if they cannot happen simultaneously in a single trial. Now understand the line, the meaning of this line. If they cannot happen simultaneously in a single trial, that events are called mutually exclusive. Means it is not possible that both the events will occur in first trial. Like for example, if we toss a coin once, then whether head will occur or tail will occur. There is no possibility that both head and tail will occur in tossing a coin once. So that means either head will occur or tail will occur. Such type of events are called mutually exclusive events. It means they cannot occur simultaneously in a single trial. There is nothing common in between that. Either head will come or tail will come. So these events are called mutually exclusive. So two events are said to be mutually exclusive if they cannot happen simultaneously in a single trial. Even in the case of rolling a dice, if we roll a dice, either one will come, two will come, three will come, four will come, five will come, six will come. There is not even a single instance in which two events occur simultaneously. So these events are called mutually exclusive events. So next we have complementary events. Complementary events. Now what is this? This is two events are said to be complementary if they satisfy all the below conditions. Are complementary if they are, the first condition is mutually exclusive. That means they cannot happen simultaneously in a single trial. They are mutually exclusive. And second is they are exhaustive events. That means together all the events became the possible outcomes of the experiment. Then such events are called complementary events. So there are two conditions. The first one is they must be mutually exclusive and the second one is exhaustive events. Means together they become the total possible outcomes of an experiment. Now I'll explain it with the help of example. In case of a coin, if I am tossing the coin once, either head will appear or tail will appear. So they are mutually exclusive events because they cannot happen simultaneously, but together they becomes the exhaustive events of the experiment tossing a coin, because tossing a coin has two possible outcomes, head and tail. So they are called complementary events. And sum of complementary events are always equal to 1, because the probability of head is there are total number of cases 2, and the possibility of favorable cases that head will occur, that is 1. So probability of head is 1 by 2, probability of tail is 1 by 2, the total becomes 1. So the sum probability of complementary events are always equal to 1. Now we'll take another one example. Now suppose we are rolling a dice and the probability that 2 or 4 will occur. So 2 or 4, they are mutually exclusive because they cannot happen simultaneously, but they are not exhaustive events, because in case of a dice we have other outcomes as well, 1, 3, 5, 7. So they are mutually exclusive but they are not exhaustive events. But if we compute the probability of odd number or even number in case of rolling a dice. So in case of odd number, we have 3 chances. We have 1, 3, 5. In case of even number, we have 3 cases, favorable cases, 2, 4, 6. Now these are mutually exclusive because they cannot happen simultaneously, and together becomes the exhaustive events of the experiment rolling a dice. So probability of odd or even, they are complementary events. So you have to understand the thing that what are the possible outcomes of that experiment. If all the outcomes are listed in a diagram, that means the sum of the probabilities is always equal to 1. They are called complementary events. Now after discussing the complementary events, the next definition that we are going to do, that is called events. I have already explained you the meaning of event. The possible outcome of an experiment is called event. Now we have various types of events. So we categorize events into first category, simple and compound events. Simple and compound events. Second category, mutually and not mutually exclusive events. Mutually and not mutually exclusive events. And third, we have independent and dependent events. So this is the classification of events. First one is simple and compound events. Second is mutually exclusive and not mutually exclusive events. And third one is independent and dependent events. Now understand the meaning of this. Simple events. If you are computing the probability of just one event, that is called simple event. Like probability of one head, probability of 4 in rolling a dice. So this is called simple event. But if you are computing probability of more than one event, then that is called compound event. This is called simple event and this is called compound event. Now for example, if I say probability of getting 2 heads in throwing a dice twice, probability of 4 and 5 in rolling a dice twice, probability of sum of 6 in rolling a dice twice, 6 and 8. So whenever you are getting finding the probability of more than one event, then this is called compound event. So this is the definition of simple event and compound event. Next, mutually exclusive and not mutually exclusive. I've already explained you the concept of mutually exclusive. That means if the two events are said to be mutually exclusive, if they cannot happen simultaneously in a single trial. So either head will appear or tail will appear, or you can say either spade card is there or club is there. There is nothing common in between that events are called mutually exclusive events. And not mutually exclusive events are those which can happen simultaneously. Not mutually exclusive events which can happen simultaneously in a single trial. Which can happen simultaneously in a single trial. For example, I want to find out the probability of ace or spade. Now, ace, there are 4 aces and there are 13 cards of spade. And there is one spade which is of ace. So that means if I draw the Venn diagram, so there is a similarity in ace and spade because one ace is of spade. So there is a chance that if I draw one card, then there is a chance that ace and spade both will happen in a single trial. We get ace as well as spade. So these events are called not mutually exclusive events, means that can happen simultaneously in a single trial. In a single trial, we can get both ace and spade. So they are not mutually exclusive events. Next we have independent and dependent events. So when we say independent, generally the definition of independent and dependent events are considered in case of compound events, means when you are finding the probability of more than one event. So independent events are those in which the first event, the occurrence of first event won't affect the chances of occurrence of second event. Chances of second event won't affect the chances of second event, means both events are independent. The first event won't affect the second event. Both are totally different. They are called independent events. Now if I say I am drawing two cards, probability of drawing two cards from a pack of cards, what is the probability that it is a king and queen with replacement? So when we write down the word with replacement, that means the first card that I have drawn is again replaced in the pack of cards. So if I ask you what is the probability of first king, so there are total how many kings are there in the card? 4. So favorable cases is 4 and total number of cards will be 52. Now we have to find out the probability of queen because this is the second event. As the first card which has been drawn is already replaced in the pack of cards, it means the total number of cards is again 52. And the probability of queen, because there are 4 queens in the card, so probability of queen is 4. It means the drawing of king won't affect the probability of drawing of queen. So they are called independent events. Whereas when we talk about dependent events, occurrence of first event affects the probability of second event. First event affects the occurrence of second event. Then we say they are called dependent events. Now what it means, let's take the example which we have already taken in case of independent events. Now we have drawn two cards, one is king and another is queen, but instead of with replacement, now we are doing without replacement. means the card that we have already drawn is not replaced or not put back in the pack of cards. So first we'll compute the probability of king. So again the probability of king remains the same, that is 4 by 52. But when we compute the probability of queen, now the total cards are 51, not 52. So it will affect our probability because now the cards are 51, not 52. And number of queens are 4. So this is called without replacement or dependent event. So make sure when the question has the word with replacement, that means the events are independent. And when the question has mentioned without replacement, that means the question is the events are dependent. So on that basis you have to solve the question. So this is just a definition which I just want to make it clear to you. Okay, what is the meaning of dependent events and independent events? So next thing is definition of probability. So when we define probability, we have already explained you that what is probability? Probability is chances of happening or non-happening of an event. So we can say probability is ratio of, we can say probability is happening or non-happening. Probability is chances of happening or not happening of an event, happening or non-happening of a future event. So now this definition, whenever we define an probability, we'll define them in three approaches, happening of a future event. So there is three theories, or you can say three approaches through which we can define probability. So the first one is classical approach. Second one is relative frequency approach. Relative frequency approach. And third one is subjective approach. Subjective approach. So we have three approaches through which we can define probability. So first one is classical or mathematical approach. So in classical or mathematical approach, probability is ratio of favorable cases to total number of cases. Ratio of favorable cases to total number of cases. So whenever we have to compute probability of any event, first we'll compute the number of favorable cases, how many cases are there which are in favor of that event, and that is divided by total number of possible cases. So this is the definition of probability, okay, according to the classical approach. But there is certain assumptions of classical approach. So what are these assumptions? First, number of trials. You can say that is fixed and finite. The first thing is number of cases should be fixed and finite. And second thing, all the events are equally likely events. Equally likely events means the probability of occurrence of each event is equal. So these are the two assumptions. The first thing is number of cases should be fixed and finite, and it is already known in advance that how many cases should be there in case of an event. So already known in advance as well. And second thing, the event should be equally likely means the probability of happening of events should be same. So this is your classical approach. Second is relative frequency approach. Now relative frequency approach says probability is limit of relative frequency of success in case of infinite number of trials. So that means the number of trials are infinite number of trials. So if I write down the formula for probability, that is limit n tends to infinite because number of trials are infinite, relative frequency of success upon total number of infinite trials. So this is the formula in case of your relative frequency. Now again, there are certain assumptions of relative frequency. First, number of trials or cases should be infinite. And second thing, all the events must be independent. Only then you can find out probability using this approach. All the events must be independent. So this is the cases when we apply relative frequency approach, or you can say this is called empirical approach, and this is called mathematical approach. And third one is subjective approach. Now subjective approach, it is based on personal knowledge or facts known to the person. So if we say who will be the murderer in case of crime, everybody has its own guesses depending upon what are the evidences or facts known to them. So this is called subjective approach, and the main limitation of subjective approach is it varies from person to person. So you may have different answers in same event. Every person has their own answers and they may differ. So it varies from person to person. So it's not a accurate method of computing probability. So that's why we won't use subjective approach. We generally use classical approach or relative frequency approach. So these are the different definitions of probability. Next thing is, I have already told you if you want to find out the probability of an event, so our classical definition will prevail, that is number of favorable cases upon total number of cases. And probability of any event always lies between 0 and 1. If probability of a certain event is 0, that means that event is impossible event. And if the probability of certain event is 1, that means that is a sure event. That's why the probability of any event always lies between 0 and 1. So, for example, you have to find out probability of getting an even number. Even number in a throw of unbiased dice. So how you can find out the probability? Unbiased dice. So first you have to understand the exhaustive events. What are the possible outcomes of a throw of dice? So we have 1, 2, 3, 4, 5, 6. So that means total possible outcomes are 6. Now we have to find out the favorable cases. Now favorable cases are, we want even number. So favorable cases are either 2, 4 or 6. That means total number of favorable cases are 3. So if we find out the probability of even number, so we have the formula number of favorable cases upon total number of cases. So number of favorable cases are 3 and total number of cases are 6. So our probability for even number is 1 by 2. Similarly, let's move to the next question. I want to find out the probability of king from a pack of cards. So I'm just finding out the probability of a king. So that means that is a simple event because I am just computing the probability of one king. So favorable cases are, how many king are there in a pack of cards? So in a pack of cards we have 4 kings. So favorable cases are 4. And total cases, how many cards are there in a pack of cards? That is 52. So that means probability of king is equal to number of favorable cases upon total number of cases. So that becomes 1 by 13. Similarly, let's move to the next question. Now suppose the next question says a bag contains 5 black and 10 white ball. 5 black and 10 white ball. What is the probability of drawing a white ball? So again I am finding the probability of a single event, a white ball. So in that case, number of favorable cases, how many white balls are there? 10. So number of favorable cases are 10 and total number of cases means total number of balls, that is 15. So our probability is 2 by 3. So this is the way how we can compute the probability of any event. For example, what is the probability of getting a number greater than 4? Greater than 4 with an ordinary dice. With an ordinary dice. Now you have to find out what are the possible outcomes of a dice. So this is 1, 2, 3, 4, 5, 6. So how many favorable cases we have? As we have to find out the probability of getting a number greater than 4. So our favorable cases are either 5 or 6. So that means there are 2 favorable cases and total number of cases are 6. So that means probability is 2 by 6. Probability of greater than 4, that is 2 by 6 or 1 by 3. Now next question is, what is the probability of getting 53 Sundays in a leap year? So this is a very important question. So we want, what is the probability that a leap year selected at random will have 53 Sundays? So as we know, the number of days in a leap year are 366. And we have number of weeks in a year, that is 52. So total weeks are 52. So according to the 52 weeks, how many days have done? Now have already gone, that is 364. That means days left are 2. So we have to find out what is the probability that out of these 2 days, how many Sundays are there. So bacha, as we know that there are 52 weeks, that means 52 Sundays are there, that's sure. But we have to find out whether the 2 days left will have Sunday or not. So we have to find out the possible combinations which are possible of these 2 days. So these 2 days may be Sunday and Monday, Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, Thursday and Friday, Friday and Saturday, and Saturday and Sunday. So out of these options, you have to check it out how many times Sunday is repeating. So total number of possible options are 7. That means total number of cases are 7. And we have to find out how many times Sunday is coming. So Sunday is coming here as well as Sunday is coming here. So number of favorable cases are 2. So probability that a leap year contains 53 Sundays, that is 2 by 7. So next question. What is the probability that a single letter selected at random from the word probability, at random from word probability. So this is the word and we have to select a single letter from the word probability, but the condition is it should be a vowel. So first, total number of letters. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total number of cases is 11. And second thing, we have to find out favorable cases. That means we have to find out how many vowels are there in the word. So we have O, we have A, we have I, and we have I. So total 4 vowels are there. So we can select any one vowel. So favorable cases are 4 and total number of cases are 11. So probability that a letter selected at random is a vowel, that is 4 by 11. Sometimes you have been given probability as odds in favor of an event. In favor of an event, that is 2:3. So sometimes probability is given in this form as well. Whenever you have been given the word favor, odds in favor, that means the first term of the ratio is favorable number of cases and the second term of the ratio is unfavorable number of cases. So if I want to find out the probability of that event, so that becomes favorable cases upon total cases. So total cases will be favorable plus unfavorable. So probability is 2 by 5. And whenever you have been given odds against an event, that is m is to n. In that case, when the word is against, the first term denotes unfavorable cases. And the second term denotes favorable number of cases. So if you want to find out the probability of that event, that is equal to n upon m plus n. So you have to keep in mind whether the term has been written in favor or against. So this you have to keep in mind. And second thing, whenever you have to find out the probability of not happening a event, means that event doesn't happen, so that is equal to 1 minus probability of A, because happening of an event and non-happening of an event both are complementary events because they are mutually exclusive and exhaustive. So happening and non-happening are complementary events. And you already know that the sum of complementary events are always equal to 1. So that means probability of A and probability of not A. The sum of both the events is equal to 1. So if you want to calculate probability of not happening of an event, that is equal to 1 minus probability of A. Clear? Now let's move to the next thing, that is, suppose you have been given question in this form. This is your empirical approach, like we have been given wages and number of workers. So we have been given wages 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80 and 80 to 90. And number of workers are 20, 45, 68, 35, 20 and 12. Whenever the question is given in this form, in that case you have to apply relative frequency or empirical approach, because the term infinite number of trials, it doesn't mean it is not possible to count, it means it is difficult to count. So in this case the number of trials are 200. So that means these are infinite number of trials. So whenever you have to find out the probability, suppose we want to find out the probability of wages less than 50, means number of persons whose wages are less than 50. So less than 50 means it includes persons whose wages are 30 to 40 and 40 to 50. It means the number of favorable cases are 20 plus 45 and total number of cases are 200. So this is relative frequency of success upon total number of infinite trials. So our answer is 65 upon 200. Now suppose we want to find out the probability of wages greater than 60 but less than 80. So that means it includes 60 to 70 and 70 to 80. So 60 to 70 and 70 to 80 comprises of relative frequency 35 and 20. And total number of trials is 200. So in that case our answer is 55 upon 200. This is called relative frequency approach. Now sometimes the question says a dice is tossed twice. Is tossed twice. What is the probability of getting sum equals to 10 in two tosses? So that means we are tossing the dice twice. So there, how many possible outcomes are there? So first you have to find out the possible outcomes. So there is a possibility that first dice has 1, second dice has also 1. First dice has 1, second dice has 2. So we have to write down all the possible cases of rolling a dice twice. So this is in this form. 4-1, 5-1 and 6-1. And this will do 2-6, 3-6, 4-6, 5-6 and 6-6. So similarly this is 2-2, 3-2, 4-2, 5-2, 6-2. These are all the possible cases of rolling a dice twice. Now understand this thing that we have one dice but we have rolled it two times. So these are the possible cases which is possible when we roll a dice twice. So these are total number of cases. So if we say total number of cases are 36. Now favorable cases, sum is 10. So now just find out where the sum is 10. The sum is 10 here, 6, 4, 5, 5. 4, 6. Now these are the three cases in which the sum is 10. So our favorable cases is 3 by 36. Any other possibility? No. So these are the three cases when the sum is 10. If I say probability that sum is less than equal to 10. So in that case, you just have to exclude these numbers. So we have 5, 6, 6, 5, 6, 6. These are the three cases in which sum is more than 10. Otherwise, in all the rest cases, the sum is less than equal to 10. So out of 36, we have decreased these three items. So our answer is 33 upon 36. Fine. Now let's move to the next thing, that is called combination. Sometimes we use combination in probability. So combination is selecting more than one item. Selecting more than one item. More than one item. So whenever there is a question that you have balls, like we have 6 red balls and 5 green balls. And we have to select 3 red balls and 2 green balls. Now this is 3 red and 2 green. That means they are called compound events. So whenever you have to find out the probability of compound events in which items are alike in nature, in that case we use combination. So combination is NCR, that is combination of n items taken R at a time, this is equal to n factorial upon n minus R factorial R factorial. That you have already discussed in combination, that's a part of your syllabus. So where n is total number of items and R is number of items to be chosen, number of items to be selected at a particular point of time, to be selected at a particular point of time. So in that case we use combination. So factorial, you already know, factorial is product of n natural numbers in reverse order, that is n, n minus 1, n minus 2, and we multiply it till 1. This is called factorial. And the 0 factorial is always equal to 1. So we have to select 3 red items and 2 green items. Make sure you must know, whenever we use combination, the default configuration is the events are dependent. The considered events as dependent means the probability of first event affects the probability of second event. So how we can find out? So we have to select 3 red and 2 green. So total reds are 6 and we have to select 3 reds from them. And total number of greens are 5 and we have to select 2 from them, and these are compound events, so we have to multiply them. These are the favorable cases. And total number of cases will be how many total balls are there? 11. So we'll say 11, but we have to select how many balls? 5. So that is 11C5. So when we apply the formula, this becomes 6C3 is 6 factorial, 6 minus 3 factorial and 3 factorial into 5C2 means 5 factorial, 5 minus 2 factorial and 2 factorial upon 11 factorial, 11 minus 5 factorial, 5 factorial. So this is equal to 6 factorial upon 3 factorial, 3 factorial into 5 factorial upon 3 factorial, 2 factorial upon 11 factorial upon 6 factorial and 5 factorial. So if you again compute it, so you can say just open 6 into 5 into 4 into 3 factorial upon 3 factorial, 3 into 2 into 1. Then similarly 5 factorial, 5 into 4 into 3 factorial upon 3 factorial, 2 factorial. Similarly in the denominator we can do 11, 10, 9, 8, 7, 6 factorial upon 6 factorial into 5, 4, 3, 2, 1. So this 6 factorial is multiplied by this, 3 factorial is multiplied by this, 3 factorial is multiplied by this. 3 2s are 6. So 2 factorial, 2 2s are 4. And similarly 5 2s are 10. 4 2s are 8. 3 3s are 9. So we have in the numerator we got 5 into 4 into 2. In denominator we have 11 into 3 into 2 into 7. So again 2 and 2 cancel. So we have 20 upon 231. So this is your answer. So combination we generally apply in those situations whenever you have to select more than one items and items are dependent. So it will cover all the possible combinations as well. So in that case we'll apply combination. For example, like from a pack of cards you have what is the probability of selecting a king and a queen. A queen. So what we'll say, how many kings are there? 4, and we have to select just one king. How many queens are there? 4. We have to select just one queen. And how many total cards are there? 52, and we have to select how many cards? 2. So this is 4C1. If we solve it, this becomes 4. So you have to understand these, you have to learn certain concepts. NC0 that is equal to 1. NC1 that is equal to N. NCN that is equal to 1 and NCN minus 1 that is equal to N. So NC1 is always equal to N. So 4C1 is 4, 4C1 is 4 and 52C2 is 52 into 51 upon 2. So if you solve it, this becomes 26. So 13 and 2. So this is 8 upon 13 ones are 13, 13 5 is 65, 66. So this is your answer. Now next thing, we define theorems of probability. Theorems of probability. So in probability, we have two theorems. One is addition theorem and second is multiplication theorem. So we have two theorems. One is addition theorem and second is multiplication theorem. First, you have to understand the situations where we have to apply addition theorem or multiplication theorem. Whenever you have to compute or probability of A or B, fine, then we have to compute addition theorem, and whenever we have to compute and, that means probability of A and B, will apply multiplication theorem. So understand this thing कि whenever we have to compute or, in that case we apply addition theorem, and whenever we have to compute and, we compute multiplication, like in this probability of king or queen. That means either king will appear or queen will appear. And whenever we have to use king and queen, means king and queen both will appear. In that case we use multiplication theorem. So in case of addition theorem, we classify events as mutually exclusive and not mutually exclusive events. Not mutually exclusive events. Now I already explained you the meaning of these terms. Mutually exclusive, that means there is nothing common in between them. They cannot happen simultaneously in a single trial. And if the events are not mutually exclusive, it means there is something common. They can happen simultaneously in a single trial. So whenever you have to use addition theorem, you have to check it out whether the events are mutually exclusive or not mutually exclusive. So if events are not mutually exclusive, that means they cannot happen simultaneously. So probability of A or B is probability of A plus probability of B. If there are three events, probability of A or B or C. That means probability of A plus probability of B plus probability of C. This is the scenario when the events are mutually exclusive. And if events are not mutually exclusive, it means they can happen simultaneously in a single trial. In that case, probability of A or B, that is probability of A plus probability of B minus probability of A and B. Because this is the common portion, this is considered in A as well and in B as well. So it is coming twice. So we have to reduce the occurrence of its common part once. So that is why probability of A or B is equal to probability of A plus probability of B minus probability of A intersection B. And if we have three events, A or B or C, that means if I draw the diagram, Venn diagram, it is in this form. This is A, this is B and this is C. So that means probability of A or B or C, that is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. Why we have done this? Whenever we are subtracting, first we have subtracted, like say A intersection B. So we have subtracted this value. This is A intersection B. Fine. Then we have subtracted A intersection B. Then we have subtracted A intersection C. So this is A intersection C. We have subtracted this value as well. So when we have subtracted B and C, that means we have subtracted this value. So when we are subtracting these things, the common part, what is the common part? This is the common part, which is common in all the three. It's totally subtracted. So that's why we have to add this value. So to consider it once. So this is the formula. If there are two items, probability of A or B, that means probability of A plus probability of B minus probability of A intersection B. And if there are three items, then we have probability of A or B or C. So the formula is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. This is your addition theorem. So next we consider our multiplication theorem. So I have already told you that whenever you have to find out the compound probability in which both the events should be there, then we have to use multiplication theorem. For multiplication theorem, we categorize events as independent events and dependent events. So we categorize them as independent events and dependent events. So I have already explained you the meaning of these terms, independent and dependent events. Independent events are those in which the probability of first event won't affect the probability of second event. So whenever we have to find compound, we have to check whether that events are independent or dependent. And I have already told you, whenever there is a word with replacement, that means the events are independent. And whenever there is a word without replacement, that means the events are dependent. So, in case of independent events, if we want to find out probability of A and B, that is equal to probability of A into probability of B. If we have to find out the probability of compound events of ABC, that means probability of A into probability of B into probability of C. This is, we have independent events. So multiplication theorem in case of independent events. But when the events are dependent, that means the first event affect the probability of another, then in that case, if we are computing probability of A and B, this is called probability of A into probability of B when A already happened. This is called conditional probability. Conditional probability. So you have to keep in mind that B will occur only when A has already been occurred. So that means probability of A into probability of B when A already occurred. This is in the case of dependent events. And if you want to find out the probability of A and B and C, so this is equal to probability of A into probability of B when A already happened into probability of C when A and B already happened. So this is multiplication theorem and how we can categorize them as independent and dependent. So whenever you have a question, the first thing you have to identify whether you have to apply addition theorem or multiplication theorem. Means there is a word or and. So when you have identified the theorem that you have to apply, so if the theorem is addition, then you have to check whether the events are mutually exclusive or not mutually exclusive, because on that basis you have to apply the formula. And if the events, if the probability theorem is multiplication, then you have to check whether the events are independent and dependent. On that basis, you have to calculate the probability. So this is how we can apply addition theorem and multiplication theorem. Now we'll do questions so that we must understand the situations when we have to apply addition theorem and when we have to apply multiplication theorem. So suppose the question is, among three events, A, B, and C, only one event can take place. So we have three events A, B, and C. Only one can take place. Only one can take place. It means या तो A होगा or B will happen or C will happen. Now the thing is, odds against A are 3:2. Odds against B, that is 4:3. Find odds against C. So this we have to compute. Now the thing is this, there are three events and only that three events are take place. So that means these three events are mutually exclusive and they are exhaustive as well. That means they are called complementary events. So that means probability of A plus probability of B plus probability of C, that is equal to 1. This is the concept of complementary events. They are mutually exclusive because they have mentioned that only one can take place. And together becomes the mutually exhaustive events because there are possibly three events. So probability of all the three events are 1. Now odds against. I have told you that whenever the word against is there, first are unfavorable cases and second term is favorable cases. That means probability of A is favorable cases upon total number of cases. So this is 2/5. Probability of B is favorable number of cases upon total number of cases. So that is 3/7. And probability of C we have to find out. So just put these values into this equation. 2/5 plus 3/7 plus probability of C equals to 1. So probability of C is 1 minus 2/5 minus 3/7. So this is 35. 35 minus 14 minus 15. So this becomes 35 minus 29, that is 6/35. Now this is the probability. But we have to find out odds against C. So that means the first term is unfavorable and second term is favorable. So we have favorable 6, that means it's in consequent, and total number of cases 35. So 35 minus 6, unfavorable cases are 29. So our answer is 29:6. Now next question. Now suppose you have been given a card is drawn at a random, a card, single card. That means this is simple event. So whenever the events are simple, we'll apply addition theorem, and whenever events are compound, we'll apply multiplication theorem. So a single card is drawn at random from a pack of cards. So now what is the probability? We have to find out the probability that it is either a club or an ace of diamond. So now just look at the question. It is either a club or ace of diamond. It means we have to find out or means we have to apply addition theorem. So first thing we have identified which theorem we have to apply, that is addition theorem. Now second thing we have to find out whether they are mutually exclusive or not mutually exclusive. It means do they have anything common or not. So either a club, club is chidiya. Okay, this is called club. If you have had a look at the pack of cards, we have 4 suits. One is spade, second is club, third is diamond, and fourth is heart. And you know, diamond and heart, that is in red in color. Diamond is in this form and heart in this form. So we have heart in this form. And spade is in this form. This is spade, and club is we have in this form. So we have 13 cards of each suit. And in each suit we have numbers from 1 to 13. So now we want to find out either a club. So I already I told you that the club there are 13 cards. And ace of diamond. Now they have particularly mentioned that ace means 1 and that is of diamond. So there is just one card of that. So means there is nothing common in that. So events are mutually exclusive. So in that case we have to find out probability of club plus probability of ace of diamond. So probability of club is 13 by 52 and probability of ace of diamond, there is just one card, so that is 1 by 52. So answer is 14 by 52. Now suppose in this case I say what is the probability that it is a spade or queen. So now again in this case we have one is spade or means we have to apply addition theorem or queen. So now we have to find out whether they are mutually exclusive or not mutually exclusive. Now spade has 1 to 13 and 12th card is queen. So there is means there is one queen which is of spade. So that means if we draw the Venn diagram, then spade and queen has one card in common and that is queen of spade. So that means they are not mutually exclusive events. So whenever we have to find out the probability of not mutually exclusive events, that is probability of spade plus probability of queen minus probability of spade and queen. So how many cards of spade we have? 13. So favorable cases are 13 and total cards are 52. Now how many cards of queen we have? 4. So favorable cases are 4 and total cards are 52. Minus the common part. There is just one card which is queen as well as spade. So this is 1 by 52. So our answer is 16 by 52 or 4 by 13. That's the answer. So this is how we can apply addition theorem in case of mutually exclusive and not mutually exclusive events. Now let's move to another one. Now suppose we have been given a question in which we'll say find the probability of two cards are drawn from random. Now I say two cards are drawn at random, one after the another with replacement. What is the probability that it is a king and queen? Now let's look at the question. Two cards are drawn at random, one after the another. Means one after another we have drawn two cards from a pack of cards with replacement. What is the probability that first card is king and second card is queen? So now just check it out. There is a word and, king and queen. So that means multiplication theorem. And we have to find out the probability of king as well as queen. That means the events are compound events. And now we have to check whether they are dependent or independent. The question says with replacement. That means they are independent events. So how we can find out? So we have to find out probability of king and queen. So that means probability of king multiplied by probability of queen. So probability of king is, how many favorable cases are there? 4, because a pack consists of 4 king and total number of cases will be 52. Now with replacement means the first card that we have drawn, we again put it into the pack of cards. So now again the total cards will be 52. So when we are drawing the second card, our total card is still 52. So what is the probability of queen? There are 4 queens, so number of favorable cases is 4. So if we multiply the both, our answer is 1 upon 169. So this is the scenario how we can apply multiplication theorem in case of independent events. Now if we change the question, if I say 2 cards are drawn at random, one after the another without replacement. So if the word is there, without replacement. So in that case, again everything is same. We have to find out compound probability and we have to apply multiplication theorem. But now because there is a word written without replacement, so events are dependent. So probability of king and queen, that is equal to probability of king multiplied by probability of queen when king has already been drawn. So sorry. So when we are drawing the king, we have 4 favorable cases and total number of cards will be 52. But once we have drawn the king, we put the card outside the pack of cards. Now the total cards will be 51. And how many queens are there? That is 4. So in this case, our answer will be 4 upon 663. So this is the difference between independent events and dependent events. I hope I have made this clear. When you have to apply addition theorem, when you have to apply multiplication theorem, how you can check it out whether the events are mutually exclusive or not mutually exclusive, and how you can check it out whether the events are independent and dependent. Sometimes they'll ask you the question probability of at least one. Now what it means, probability of at least one means either one or both the events will occur, or both the events will occur. Now suppose I'll take an example. Now question says a problem in stats is given to 3 persons. Problem is given to 3 persons. Fine. So problem is given to 3 persons. Now says the chances of solving the problem by A is 1 by 2. The chances of solving the problem by B is 1 by 3. And chances of solving the problem by C is 1 by 4. Now find out the probability that problem will be solved. Now our main focus is the problem should be solved. So that means either the problem should be solved by 1 person or 2 person or 3 person. So that means we have cases. So how many cases we have? We say A has solved the problem, B has not solved the problem, C has not solved the problem. Or you can say A will not be able to solve the problem, B has solved, C has not solved it. Or you can say A not, B not, C. So this is the situation, cases when one person has solved the problem. When we say problem will be solved, so that means we have one person, 2 person or 3 person. Any number of persons can solve, but the problem should be solved. It means there should not be scenario where the problem is not solved by anyone. So that means these are the cases when one person has solved the problem. Now if we'll move to those cases when 2 persons will solve the problem, A, B, C not, A, C, B not, or A not, B, C. So this is the scenario where 2 persons has solved the problem. And now the next case, all the three persons have solved the problem. This is ABC. Now this is the case when three persons have solved the problem. Now we have just one case in which none of the person has solved the problem. So when we say at least one, so at least one comprises of one person, two person and three person. So either we have to solve all these cases and we have to add the probabilities. So if you know that all these events are mutually exclusive and complementary, so sum of all should be 1. So if I subtract that none of them will solve the problem from 1, that means this is the case of at least 1. So whenever you have to find out probability of at least 1, the simplest method is subtract probability of none from 1. So this will comprise all the cases in which either one probable person has solved the problem, or two person has solved the problem, or three person has solved the problem. That means 1 minus probability of A naught, neither A has solved the problem, neither B has solved the problem, neither C has solved the problem. So that means 1 minus, because these events are independent, so we simply multiply the probability of these three. So we have the probability of selection. So probability of not selection, yeah, not solved, that is 1 minus. So this is 1 by 2. Probability of B naught, that is 2 by 3. And probability of C naught, that is 3 by 4. So just put these values, 1 by 2 into 2 by 3 into 3 by 4. So this is cancelled, this is cancelled. So 1 minus 1 by 4, your answer is 3 by 4. So this is how you can solve when you have been given problem will be solved, bridge has been destroyed, target has been hit. So in that case you have to use at least 1. That means 1 minus probability of none. Now there are certain cases in the, now let's do the question of conditional probability. Now suppose you have been given the question. Now the question says two cards are drawn, one after another, without replacement. What is the probability that both are aces? Means the first card is also an ace and the second card is also an ace. Means we have to find out probability of first ace and second ace. So now the condition is without replacement, means there is a conditional probability that we have to find out the probability of first ace, then we have to find the probability of second ace when first ace has already been drawn. So probability of first ace is how many aces we have, 4, and how many cards we have, 52. So this is 4 by 52. But when we are trying to find out the probability of second ace, now the cards are 51 because the first card that we have drawn is not replaced. So the total number of cards are 51. And how many aces we have? Now we have aces, that is 3, because first ace we have already drawn and put it on one side. So the probability of second ace is 3 by 15. So if you find out, this is 1 by 13 and this is 1 by 17. So our total probability is 1 upon 221. This is called conditional probability. Sometimes question is given in some another form as well. Like for example, if I say probability that a management trainee will remain with the company. So probability is 0.60. Okay. So probability that employee earns more than 50,000. Per annum, that is 0.5. Probability that an employee's management trainee remained in an office, remained in company, or earns more than 50,000 per annum, that is 0.7. Now what is the probability that employee earns more than 50,000 per annum, more than 50,000 per annum, given that he is a management trainee, he is a management trainee and remain in a company and stayed within a company. Now let's solve this question. This is a very good question. First understand the meaning of the terms given in the question. Now probability that a management trainee will remain with the company. Suppose this is A. So probability of A is 0.60. Probability that employee earns more than 50,000 per annum. So suppose this is probability of B, that is 0.5. Probability that management trainee remained in a company or earns more than 50,000. That means this is probability of A or B, that is 0.7. Now the question they ask, what is the probability that employee earns more than 50,000 per annum, given that, whenever they write down in this way, given that, subject to, he is a management trainee and stayed within a company. You know that employee earns more than 50,000, this is your B, and the management trainee stayed within a company is A. So what the question they are asking, probability that B is there, given that means this is a conditional probability that he is a management trainee and stayed in a company. So we have to find out the value of probability of B given that A. So this is the case of conditional probability. You have already done that probability of A and B in case of conditional probability is probability of A into probability of B given that A has already occurred. So if I want to find out probability of B given that A has already occurred, that means probability of A and B upon probability of A. So now the most important thing is I have probability of A but I don't have the value of probability of A and B. So I have to find out the value of probability of A and B. So that I'll find out from probability of A or B. So what is this? Probability of A or B means they are not mutually exclusive events. So probability of A or plus probability of B minus probability of A and B. So probability of A or B is 0.7. Probability of A is 0.6. Probability of B is 0.5 minus probability of A and B. So probability of A and B, that is 0.6 plus 0.5 minus 0.7. So this becomes 0.4. So this is probability of A and B. So now we want to find out probability of B when A already occurred. So that is probability of A and B upon probability of A. So probability of A and B is 0.4 and probability of A is 0.6. So our answer is 2 by 3. This is how you can compute the value of conditional probability. Now next question, just look at this question. Now the question says, A speaks truth in 80% cases. A speaks truth in 80% cases and B speaks truth in 90% cases. In what percentage of cases they are likely to contradict each other? they are likely to contradict each other. So now this is the scenario when we have to use both the theorems, addition theorem as well as multiplication theorem. Now question says A speaks truth in 80% cases. That means probability that A will speak truth, this is 0.8, and probability that B will speak truth, that means 0.9. Now my question says they are likely to contradict each other. Contradict each other means either if A is speaking truth, then B is speaking lie. Or if B is speaking truth, then A is speaking lie. So we have two cases. The first case is A truth, B lie. And second case is A lie, B truth. So these two cases are mutually exclusive, means they cannot happen simultaneously. So for computing the probability of cases, we'll use multiplication theorem. But to find out the total probability, we use addition theorem. So first we compute multiplication probability of A into probability of B complement, because these events are independent. So probability of A truth is 0.8, probability that B will lie, that is 0.1. So this becomes 0.08. And this is probability that A will speak lie into probability that B will speak truth. So A will speak lie, the probability is 0.2, and B will speak truth, the probability is 0.9. So this is 0.18. So we have to find out the probability. So that means probability of case 1 or probability of case 2. So now here is the addition theorem. So the events are mutually exclusive, cannot happen simultaneously. So this is 0.08 plus 0.18. So total probability will be 0.26. And if they say percentage of cases, then multiply it by 100. So there are 26% of cases in which they are likely to contradict each other. Now, sometimes we have certain complicated questions as well. Now, what type of complications are there? Let's do that. Now, suppose the question says a bag contains 4 copper coins and 3 silver coins. And the second bag contains 6 copper coins and 2 silver coins. Now the question is, a coin is taken from any purse. A coin is taken from any purse. Find the probability that it is a copper coin. Now first understand the question. The question says a bag A. Now we have A bag that has copper coins and silver coins. So there are 4 copper coins and 3 silver coins. We have another bag B, that comprises 6 copper coins and 2 silver coins. Now they say a coin is taken from any purse. That means we haven't defined from which purse we have to draw the coin. Means we have to take the probability of purse as well. But they say the coin should be copper coin. So now we have cases. The case 1 says we have selected bag A and copper coin. So now this is, we have compound probability. So because they are independent, so we'll say probability of bag A into probability of copper coin. So probability of bag A, see, because we have total 2 bags, so favorable cases is 1, so 1 by 2. And probability of copper coin in bag A, we have 4 copper coins and total coins will be 7. So 4 by 14, that is the case 1. Now we have the case 2. Case 2 says bag B and copper coin. So we have probability of bag B into probability of copper coin. So what is the probability of bag B? Again we have 2 cases and favorable number of cases will be 1. And probability of copper coin in second bag, we have 6 favorable cases and total favorable cases are 8. So this becomes 6 by 16 or 3 by 8. So now the total number of cases. So there is either case 1 will happen or case 2. So probability of case 1 or case 2. So that is both the events are mutually exclusive. So probability of case 1 is 2 by 7 and probability of case 2 is 3 by 8. So we have to add them. So this becomes 56, 16 plus 21. So our answer is 37 upon 56. This is our answer. So this is how we have to apply both addition theorem as well as multiplication theorem in such questions. Now suppose another question will do. Bag A contains 1 black and 2 white balls. Bag B contains 2 black and 1 white ball. Now question says a ball is drawn from first bag. A ball is drawn from first bag. Now they have mentioned that we have drawn the first ball from first bag and then put it into the second bag. To the second bag. And then a ball is drawn from second bag. And then a ball is drawn from second bag. So now our question is, what is the probability that it is a white ball? So this is again a very good question. So the question says there are 2 bags and both bags will comprises of black and white balls. So now the question says we have drawn 1 ball from first bag. But we don't know which color of ball we have drawn from first bag. And then we put that ball in the second bag. And after that we have drawn 1 ball from bag B. So we have to find out कि whatever the ball is drawn from bag B, it is a white ball. So we know which color ball we have to draw from bag B, but we don't know which color of ball we have to draw from bag A. So what we'll take our first case. We'll say कि from bag A we have drawn black ball and from bag B we have drawn white ball. So that means probability of black and white. So they are independent events because both the balls are drawn from different bags. So probability of B into probability of white when black has already been drawn. So what is the probability of drawing a black ball from bag A? So we have 1 favorable cases and total number of cases are 3. And now we have put this black ball into bag B. So now the number of black balls in this case is 3. These events are dependent, not independent. Okay. So now the total number of black balls is 3 and white ball is 1. But we have to draw white ball and total number of balls become 4. So this becomes 1 by 12. Now second case is we have drawn from A bag we have drawn white ball and from B bag we have also drawn white ball. So that means probability of first white from bag A and probability of second white from bag A when first white has already been drawn. So probability of first white in bag A, that becomes 2 by 3. Favorable cases are 2. and probability of white from bag B. Now the total number of white balls in bag B are 2 because the ball which we have drawn from bag A is white, and when we put it into bag B, the total number of white balls becomes 2. So favorable cases are 2 and total cases are 4. So this becomes 4 by 12. So both these cases are mutually exclusive. Either case 1 will happen or case 2 will happen. So whenever the word is or, we'll use addition theorem. So that means probability of case 1 plus probability of case 2. So probability of case 1 is 1 by 12 and probability of case 2 is 4 by 12. So our total answer is 5 by 12. So this is the answer. Now let's move to the next question. Now next question says, bag A contains 10 white and 3 black balls. Another bag B contains 3 white and 5 black balls. Now the question is, 2 balls are drawn from bag A. 2 balls are drawn from bag A and put into the bag B. Now in the last question we have drawn 1 ball from bag A and put it into bag B. Now we have drawn 2 balls from bag A and put it into the bag B. Okay? And a ball is drawn from bag B. And a ball is drawn from bag B. Bag B. What is the probability that it is white ball? Now again the same question in which we know that which color ball we have to draw in bag B, but we don't have any knowledge which color of ball we have to draw from bag A. So in that case we have to cover all the possibilities. So first possibility, case 1, bag A, bag B. We have drawn 2 white balls from bag A and 1 white ball from bag B. So whenever we have to draw more than 1 balls or more than 1 items which are alike, then we generally use combination. So how many white balls are there in bag A? 10. So that means 10 C2 upon 15 C2. Then we have to draw another white ball from bag B. So number of white balls in bag B becomes 5. So now 5C1 upon 10C1. So this is the probability of case 1. So this is 10C2 means 10 into 9 upon 2 upon 15C2, 15 into 14 upon 2. So and 5C1 is 5 and 10C1 is 10. So this 10 is cancelled by 10. So this is 2, 3 and then 3, 3 and 2, 7. So this becomes 3 5s are 15 upon 70, or you can say 3 upon 14. So this is the case 1. Second case, we are drawing 2 black balls from bag A and white ball from bag B. So in that case, there are 3 black balls. We are drawing 3C2 upon 15C2 into. Now white balls are 3, 3C1 upon 10C1. So 3C2 is 3 and 15C2 is 15 into 14 upon 2 into 3 upon 10. So this is 2 7s are 14, 3 5s are 15. So this becomes 3 upon 350. Now next we have third case. In third case, we take the possibility that we have drawn one white, one black ball from the bag A and we are drawing another white ball from bag B. So in that case, what we'll do, we'll say 10C1 into 3C1 upon 15C2. Now the total white balls become 4. 4C1 upon 10C1. So this is 10 into 3 upon 15 into 14 upon 2 into 4 by 10. So this becomes 10, 10, 3 5s are 15 and this 2 will be multiplied by 2 7s are 14. So this becomes 4 by 350. No, 4 by 35 only. 4 by 35. So now these are the possible cases. So all these cases are mutually exclusive. It means they cannot happen simultaneously in a single trial. So what we'll do, we'll say probability of case 1 or probability of case 2 or probability of case 3. So the first value is 3 upon 14. Second value is 3 upon 350 and fourth value is 4 upon 35. So you have to just add it. So whatever the answer is, that will be your answer. So these are different types of questions that comprises of certain addition theorem, combination of addition theorem as well as multiplication theorem. Now let's do one more question. Now next question says 3 coins are tossed simultaneously. Tossed simultaneously. What is the probability that there will be 2 heads and 1 tail? So in that case, you have to write down all the possible cases. When the 3 coins are tossed, there is a possibility that all the 3 coins have heads, or you can say head, tail, head, 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 tail, and tail, head, head. Now these are the arrangements in which, in this case, there are 3 heads. These are the cases in which there are 2 heads. And now the cases in which there are 1 head. So this is tail, head, tail, 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 head, head, tail, tail. Now this is the case in which there is 1 head. And this is the case when there is no head. So we have to find out 2 heads and 1 tail. So 2 heads and 1 tail means this is the scenario. So two favorable cases are 3 and total number of cases are 8. So probability is 3 by 8. Fine. Now we can say another question. So question says A can hit a target. A can hit a target 4 times in 5 shots. That means probability that A will hit a target, that is 4 out of 5, because number of favorable cases is 4 and total cases is 5. B can hit a target 3 times in 4 shots. So probability of B is 3 by 4. And C can hit a target 2 times in 3 shots. So that means probability of C is 2 by 3. Now the question is, they fire a volley. That means they fired at the same time. What is the probability that at least 2 target hits? Now in this case, they say at least 2. That means 2 or more than 2. So in that case, you have to find out the cases in which either 2 persons hit the target or 3 persons hit the target. So we have first case, A hit the target, B hit the targets, C is not able to hit the target. Second case is A and C hit the target, B is not able to hit the target. A third situation is in which B and C hit the target but A is not able to hit the target. And fourth is, this is the scenario when two persons hit the target, and next is in which all the three persons hit the target. Because our question says at least two, that means two or more than two. So what we'll do? Probability of A into probability of B into probability of C complement, because these are compound events. Probability of A into probability of B complement into probability of C. Probability of A naught into probability of B into probability of C. And last we have probability of A into probability of B into probability of C. So probability of A is 4 by 5, B is 3 by 4, not C is 1 by 3. So this becomes 1 by 5. Or you can say, just write down in simple way, 12 upon 60. 12, what was it, 23 is a 60. Now probability of A 4 by 5, B naught 1 by 4, C 2 by 3. So this is 8 upon 60. Probability of A naught 1 by 5, B 3 by 4, C 2 by 3. So this is 6 by 60. And probability of A 4 by 5, 3 by 4 and 2 by 3. So this is 24 by 60. All these events are mutually exclusive. It means they cannot happen simultaneously. So we have to add the probabilities of each of the cases. 12 by 60 plus 8 by 60 plus 6 by 60 plus 24 by 60. So this becomes 38 plus 12, 50. So answer is 50 upon 60 or 5 upon 6. So this is the scenario when we have a case of at least two, not at least one, at least two. Let's do another question. Three groups of workers. We have men, women, and group 1 comprises of 3 men and 1 woman. Group 2 comprises of 2 men and 2 women, and group 3 comprises of 1 man and 3 women. One worker is selected at random from each group. What is the probability that it consists of 1 man and 2 women? So we have been given the final outcome that number of persons selected are 1 man and 2 women, but we don't know the order in which we have to select it. So in that case we have to make cases. Case 1, this is group 1, this is group 2 and this is group 3. So what we are doing, we are selecting 1 man from group 1, 1 woman and 1 woman. Or we can say case 2, we are selecting 1 woman, 1 man and 1 woman. And third scenario is 1 woman, 1 man, because we have to select 1 person from each group. 1 worker is selected at random. So there are 3 cases. So first case says the probability that man is selected, that is 3 by 4. Then woman is selected, that is 2 by 4, and again woman is selected, 3 by 4. So this becomes 3 to the 6, 3 is 18 upon 64. Now 1 woman, that is 1 by 4, then men 2 by 4 and again woman 3 by 4. So this is 6 by 64. And in third case 1 woman from group 1, 1 by 4, 1 woman from group 2, 2 by 4 and men from group 3. So this is 1 by 4. So this becomes 2 by 64. All these cases are mutually exclusive, means they cannot happen simultaneously. So we have to add the probability. So 18 by 64 plus 6 by 64 plus 2 by 64. So this becomes 26 by 64 or 13 by 32. This is the answer. So this is all about probability, bacha. I hope I have made you clear each and every concept of the probability. Now you can ask for queries. Thank you. Thank you very much.